You're going to take the Module 2 assessment today. It is a district benchmark test, and so in this video I'm going to go through a number of questions that will help prepare you for the exam. The first one says, given 5 different logarithmic expressions below, which option correctly places them in order from smallest to largest? So I'm going to use the Desmos calculator and I'm going to plug these in. So I'm going to start with the first one, and I'm literally going to look up the values of each of these. Remember, we're going to hit the keypad when you're doing this by yourself. You're going to hit functions, make sure that miscellaneous is highlighted, and then log base A. So the first one was log base 2, and then inside the parentheses was 200. I got to use the arrows to get inside. And what should you write down? You just need to write it down so that when you need to place them in order, you have. So I'm going to write it down to let's say to the hundredth, so 7.64. The second option was log base 2 of 2, and that answer is 1. The next one is log base 2 of 0.02. The third one is log base 2 of 120. And the last one is log base 2 of 1. So I'm going to come back to the screen, and now I'm going to look at the order. Again, I want to write them from smallest to largest. So the smallest would be the negative, so it needs to start with 3. Anything that does not start with 3, I cancel it out. Okay, got that one done. And now out of these, the next smallest one is 0, which is option V. This is option V. There's only one option. Let's just make sure that I didn't make any mistakes when I created this self-assessment. So I've got this one done, and this. The next smallest one would be 2, option 2, then option 4, and then option 1. Question number 2 is going to compare two different functions, function f of x and function g of x, and they want to know which statement of these is true. So I'm going to pause, I'm going to go into Desmos, and I'm going to go through and graph both. Okay, so I've gone into Desmos and I have plugged in y equals this function and y equals this function. You'll see that. And then I'm going to actually draw a little picture of what it looks like, and then I'm going to come back here and analyze the options to decide which one is true. Notice that the blue represents the exponential one and the logarithmic function is in red. So on my piece of paper, I'm going to draw a little graph of this, and let's see if I have 2 different highlighters. I think that will help. And it does not look like I have 2 different highlighters, but I have 2 different color pens here. So in red, also notice that the x-intercept is right here. X-intercept is at 1. Okay, and it looks like that. And then notice for the exponential that the y-intercept is at 1. And by the way, here's the first thing that I'm thinking of. First thing I'm thinking of is, look at this. Do they directly reflect across this line? If I folded along the green line, I can see that they look like they're exactly the same. I want to prove this. So look at, I just was able to decide that 0, 1 was a point. And now if I flip that, I should come up with 1, 0. Let's do one more point to make sure this is making sense. So it may not be an exact point here, but let's see here, 1, 3. Okay, 1, 3. So I'm going to change this and now do 1, 3. And now if this is our inverses of one another, this better be 3, 1. Remember how the domain, or you could use the word inputs, okay, or x values, the domain of one function becomes the range of the next. The range of the first becomes the domain of the second. And I can see that they're both on the graph. So these are actually inverses of one another. So I went through here and I graphed, here's g of x and here's f of x. I can see with g of x that there's a horizontal asymptote at y equals 0. It never is going to cross the x-axis. And for the function that is in blue, f of x, there's a vertical asymptote. It's never going to cross the line y equals 0. Okay, and I've already proved that they're inverses of one another. I can see they are going to reflect across the line y equals x. What else do I see? I picked out 2 points. I picked out 0, 1, and then I flipped it 1, 0. I did 1, 3, and then 3, 1. So I proved that again, the domain and ranges are going to flip-flop from one function to the next. So could I go through here and do each one? Sure. Or there's a one true statement. I'm going to see if it has anything about domain and range. Here we go. The range of one function is the exact same as the domain of the other. Done. Okay, so for question number 3, it says, which of the following statement or statements is false? Okay, so remember when you look at this, remember this is the base. If you don't remember from last week, you may want to write this down. This is the exponent, and this is the answer. Base, exponent, answer. So when I rewrite this, 5 squared equals 25. So what they're saying is this is true. This is a true statement because 5 squared is 25. This is true, so I'm going to put true behind it. I'm trying to figure out which one is false or which ones are false. Okay? That says that this is true because 7 raised to the first power is 7. Remember, this is the base, this is the exponent, this is the answer. So 7 to the first is 7. Is that true? Yeah, 7 to the first is 7. This is also true. So if you want, we can cross out the true ones. We're trying to identify the false ones. Okay? This says 3 to the 0 power is 0. 3 to the 0 power is 0. Well, let's go back and check that. That is actually not a true statement, but a lot of students believe it is true. I want to show you how. You can come up here, type in 3, raise it to the 0, and we can see the answer is not 0, the answer is 1. The answer is 1. So let me come back here. We know that this is a false statement, so I know for sure that C is one of those choices I want to select because I'm looking for false statements. Now, log base 11 to something. Well, let's see here. This would mean if I don't know the answer, I'm going to put a question mark or an X. So 11 raised to the I don't know what, we could put an X. 11 raised to the X equals the answer. This is the base, this is the exponent, this is the answer. This is the base, this is the exponent, and I put an X there, it's the unknown, and this is the answer. That says this is not even possible because there's no value of X that you can take 11 to. In fact, it doesn't matter what the number is. It doesn't matter what that number is. There exists no number that you can raise it to. I should have put a question mark here. There exists no number you can raise it to, and you get an answer of 0. So this is true. We can't raise 11 to something and come up with an answer of 0. So there is only one false statement, and that would be option C. Okay, so if this statement is true, then what is X equal to? Remember, this is your base, this is your exponent, and this is your answer. So base, exponent, answer. So I need to think, what number can I raise to the 4th power? Remember, this isn't multiplying. What number can I raise to the 4th power and I end up with 16? That means take whatever this number is, times itself 4 times, you get 16. So let's try it. Let's start with the first one. We know only one of these is a true answer. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Right off the bat, we're able to identify. And 5 through, I believe 5 through 8, they want us to evaluate the expression. Now, if you have that table, you can go pull up the table, but we can use actually the calculator in Desmos in order to evaluate this. So log base 3 of 81. How do we do that? So I'm going to jump over here. Remember, to get to the log, you're going to hit functions. If miscellaneous is not highlighted, click on it, and then log. And the base is 3. I'm going to use the arrow to go inside. It evaluates it, and the answer is 4. Exact same question. If we didn't have a calculator, we would talk about the thought process here, but I'm simply going to go in here, and I'm going to switch out the 3 to a 6. Inside parentheses is a 1 divided by 6, end the parenthesis, and I get an answer of -1. Identifying the value of this expression, so log of base 210 of 210. Coming back here, some of you will just know that when the number down below the base is the same as the number inside, we get an answer every single time of 1. If not, you can plug it right into the Desmos calculator. This particular problem you cannot plug into Desmos, and here's what you have to know. So this is a property of logarithms. Whenever you have an exponent, this exponent is going to jump out front every single time. So the 5 comes in front, and now I have log base x of x. And just like we had in the last problem, if I move this down briefly, when this number or value is the same as this number or value, exactly the same, this evaluates to 1. So we can see here, regardless of what x is, whether it's 3 or 210, whatever it may be, when this number is the same as the number in back, this is going to simplify to 1, and now I have 5 times 1 is 5. Number 9, similar to 5 through 8, this does not have a variable, so I can come back up here and I can plug it in. Log base 11 of 1. So I'm going to change the x to 11, behind to a 1. I'm going to eliminate this, and we should be able to see, whoops, let me start over by plugging this in. And we can see the answer is 0. Solve the equation and round your answer to the nearest tenth. Okay, so what you need to recognize is that 25 and 125 can be rewritten having the same base. So if you had that table in front of you, you'd be looking at the table and going straight across until you were able to come up with the number. And so since you're unable to show the screen, I do want to show you where can you find that. So I'm going to come over here and go to Teams. Every single class has it. If you get to the test and you don't have that table, I do want to show you really quick. It's in a post. Give me 1 second. We need to go back maybe about a week and a half. I'll find the exact date. You can write it down. So if it happens to be that you get to a question, you have to have the table, and you don't have it available, you can look back to. There it is. That's the table. Oh, excuse me. Please write down November 16th. November 16th if you need to rely on this table. So 25 and 125 were the two numbers. If I pop back here, 25 and 125. Now you may be saying it wasn't 125, it was 1 over. Only look at the base number here, so 25 and 125. So I'm going to go back to that table that we were just looking at. And I go, okay, which line here has a 25 and a 125? Well, there's a 25, there's a 125. So I can rewrite 25 as 5 squared. I can rewrite 125 as 5 cubed. Okay, so here we go. This is 5 squared, and this is 5 cubed. But now here comes the part. The 125 went to the bottom. It wasn't on top, so I need to identify it with a -3. Remember, when you write down the remaining parts, it's important that you do put it in parentheses. So if you remember how to do this, go ahead and see if you can finish it before I can. As long as the bases are the same, they cancel. Remember, this 2 has to be delivered to both, or distributed to both, along with the -3. Move the x's to one of the two sides, up to you. Now remember, this is a district exam, so it's really important that we go back and look at how do we want the answer to be represented. It says round your final answer to the nearest tenth. Okay, so if you don't know what this is right off the bat, as a decimal, you go back into Desmos, clear it out, and I'm going to go 1 divided by 5 is 0.2. So when I come back here and look, it is x equals -0.2. Number 11 is we're going to solve the equation and round the final answer to the nearest hundredth. So I first want to get 7 by itself. So I'm going to rewrite this here. So first let's get 7 by itself, and then we'll work on isolating the x. So I'm going to divide both sides by 3. Remember, the only reason you learn logs, the sole purpose is so that you can solve for a variable that is in the exponent position. So how do we do that? Well, this is what I want to get rid of. I want to get rid of the 7. So I'm going to do log base 7 to both the left and the right. And then I'm going to write down what was there. So 11 was there, and 7 raised to the x plus 1. On the left-hand side, the log base 7 and the 7, they don't just cancel out. Really, they are going to simplify into a 1. And I'm going to bring down the x plus 1. Now, multiplying by 1 is not going to change anything. So I have x plus 1 equals log base 7 of 11. Now, we're supposed to get an answer and then round it to the nearest hundredth. So whatever this value is, once I get this value, in order to isolate the x, I need to subtract 1 from it. So first get this value and then subtract 1. If you don't put this in parentheses and we plug it into Desmos, Desmos is going to think what we want to do is go log base is 7, log base 7, and then they're going to think it's going to be of 10. We need to put this in parentheses. That means get this answer and then subtract 1. Okay, so I know I'm going to have to round here, and round to the nearest hundredth specifically. I'm going to come over here, start it again. Function, miscellaneous, log base A. Okay, so this was, I'm going to, start with the parenthesis first, then we'll hit that function. Log base 7 of 11, so I'm ending the parenthesis for the 11, and I'm ending the parenthesis for that log portion. And then I'm going to subtract 1 behind it, and now rounding it to the nearest hundredth. So approximately 0.23. I look at the 3, the number behind it says nope, don't round up, and this will be my final answer rounded. Give me 1 second. So in problem number 12, they're going to ask us to look at options A through D and select which one correctly models this equation. So the first thing I'm going to do is I'm going to graph this in Desmos. So remember, it's a y equals, and I'm going to go down to y equals. In our particular equation, it was -2, and then the function log base 3 inside, using the arrows to get inside the parentheses, was an x plus 1. Now, how can I look at this and determine which one it is? Well, the first thing is I can see that from left to right it goes down. From left to right it goes down, and I can see that it goes directly through the origin. So I'm going to draw myself just a really simple graph, and I can see it goes down and it goes right. Oh, if I could draw a little bit better graph there. 1 second. I'm doing this on paper, just a sketch. Okay. So I went ahead and I drew what I see here. I see it goes down and has an origin of 0, 0. So now I'm going to go one by one. See, okay, this is not in this correct shape. A is not it. This is in the correct shape, and it does go through the origin. That could be it. This is in the correct shape, but it doesn't go through the origin. This is not in the correct shape. My final answer is option B. We're going to do the same thing for number 13. So we have 4 options, and we want to select which one correctly models this equation. So I'm going to come back to Desmos, and it starts with a -3 plus -3 plus log base 3. Inside is x subtract 4. Okay, let's see what we have here. All right. Okay, so it looks like the only thing I can really tell here is it looks like there is possibly a vertical asymptote here at 4. So if that cuts through the x-axis, let's just look here. Yeah, it looks like that's the vertical asymptote. Okay, and I can see the shape of it. So I'm going to create this graph on my paper. 1, 2, 3, 4. And then again, on this test, you'll never have to actually directly graph something. And now I'm going to switch the screen so you can see. And I want this shape. So first of all, okay, we've got the right shape, we've got the right shape, we've got the right shape, wrong shape. Okay, so I have a 1/3 chance of getting this right. So what I'm going to do right now is I think the stanza is I'm going to look for which one looks like it has a vertical asymptote at 4. So here's 5, here's 4, that looks pretty good. Here's 4, that looks pretty good. Here's 4, that is definitely not it. That does not have a vertical asymptote. Now between the two, notice that this is below the x-axis. This is above the x-axis. This is below the x-axis. That makes A the correct choice. If you know that the left side is equal to the right side, which is 0, then which one of these is not a true statement? So let's just first think of this. I have 2 things. I'm going to circle them. I have 2 things. And if I subtract those 2 things, I end up with 0. So let me write that down. If I have, let's just say, let's call this A and let's call this B. So A subtract B equals 0. Then what could we say is true? Well, if these two subtract to equal 0, then I know that these two have to be equal to each other. Because in order for you to get 0, like 2 subtract 2 is 0. They have to be the same. 3 subtract 3 is 0. So these two have to be equal to one another. So when I look back here, if they're going to be equal to one another, they have the same base of 3. But inside the parentheses, I have 11 here and I have x. That means this x actually must be an 11 if the two are going to be identical. Because remember, when you subtract two identical things, you always end up with 0. So x equals 11 is a true statement. And so I'm going to actually cross it out because I am trying to identify the false statements. Also notice that if this is a true statement and these two are identical, then they have to be equal to one another. So log base 3 of x is equal to log base 3 of 11. Also a true statement, so I'm going to cross it out. Now what is brand new to you is we use the words expanding. So you're taking something, you're expanding it or contracting it. Those are two words we're going to use from now through the end of this review. Expanding means to pull apart, contracting means to push together. Now when we do that, this is new to you, you probably want to write this down. When we expand things, multiplying turns into addition and division turns into subtraction. This is when we expand it, this is when we contract it. So notice that right now I have subtraction. Right now I have subtraction. So if I'm going to take subtraction and I'm going to, instead of expanding it, I'm going to go backwards and I'm going to contract it, which means I'm going to rewrite this in a way that just pushes it together, but it's the same thing. Subtraction goes into division. So this would be first, so it's on top. This is second, it's on the bottom. So when I look here, here we go. They have the same log base 3. You can only do it if they're the same base of the log. And then this is the first one, so it's on top. This is the second one, it's on the bottom. Also a true statement. The only false statement is option. So here we're asked to expand this, and then select which option is below. So there's two things. Remember, if I go back up here, when I expand things, when I want to go from contracted to expanded, multiplying turns into addition. So keep that in mind. Multiplying turns into addition. So right now, if I would do this the slow way, I would have log base 5 of 11 times x to the 5th. Right? That's really what's happening when they're pushed together. To expand it, multiplying turns into addition. So log base 5 of 11 plus log base 5 of x to the 4th. And the last thing is, as we went over earlier in this review, if you have an exponent, the exponent needs to sneak in front of the log. So log base 5 of 11 plus 4 log base 5 of x. Let's find that option. It is option. This is the exact same thing for number 16. We're going to expand this. Notice there was multiplying here, so I'm going to do log base 6. And I'm just going to do it slowly so we can see. This is going to be 5 times x to the 4th. By the way, does this look like the last problem we just did? Give me 1 second. Very similar, not exact, but very similar. Okay, so again, when I'm going to expand this, I'm going to write on this piece of paper, I have log base 6 of 5. Remember, multiplying turns into addition, and log base 6 of x to the 4th. Wherever the multiplying was, it turns into addition. Now, there's nothing we can do here, but over here, we have an exponent, so it needs to sneak in front. Log base 6 of 5 plus 4 log base 6 of x. Final answer. On problems like this where you do have multiple ones, I will say that several of these that have 4 to 6 options to them, like 4 to 6 little mini problems within one problem, they have on the left-hand side is the question that they want, or the expression that they want you to expand, and then on the right-hand side would be the answers, and you have to match which one goes with which. Okay, number 17. Here we go. So we're going to expand this. Now we have division. Remember, division turns into subtraction. So log base 6 of x. Why am I doing x first? Because it's the top one. Division turns into subtraction, and log base 6 of 5. Done. Good. We finally get to challenge you guys with something a little bit harder here. Number 18. So first I see that there is multiplying. So log base 2 of 8 times x. Log base 2 of 8, and then I change this into addition, and log base 2 of x. But here's the deal. If we go back to this chart, we're going to see that 8 actually can be rewritten with a base of 2. So if I'm able to flip and see that chart, notice that with a base of 2, I can rewrite 8 as 2 to the 3rd power. So log base 2 of 2 to the 3rd, log base 2 of 2 to the 3rd, 2 to the 3rd is the same as 8, plus log base 2 of x. And now remember, we got an exponent, got to put it in front, so I have 3 log base 2 of 2 plus log base 2 of x. One last thing, and we did already learn this in the last week and a half, when the log base 2, or the log base of whatever this may be, and this number are exactly the same, remember they don't just cancel out, they really turn into a 1. 3 plus log base 2 of x. Final answer. Number 19, again I have division and I want to turn it into expanded form. Division turns to subtraction, so there's the numerator, subtract the denominator. Now you may be wondering, well, like, why here are you not trying to change something? Like over here you changed it to 2 to the 3rd, but why are you not doing that here? Because I know there's no way to rewrite 5 with 6. Like if this was a 36, I would write 6 squared. If this was a 216, I would write 6 to the 3rd. But I know that 5 cannot be rewritten in the 6th category. And you can see that by if I go over to the 6 here and I go across in 6, I never just see a 5. This problem is totally simplified. Let's look on to number 20. Just a few left to do. This is definitely a more complicated one. Notice that the 5 is not just being applied to the x, it's being applied to 2x. So I'm going to start by thinking about this. What can we do? Let's have you guys attempt this one, knowing that this is one of the hardest ones. The next 2 problems after this are quite easy, and then we're done with the review. So I'm going to put it on pause. Let's see what you can do, and then come back. Okay, so the first thing I'm going to do is I'm going to bring this down in front of the log. So 5 log base 2 of 2 times x. Okay, now when I rewrite this log, when I rewrite this 5 times this log base 2, it needs to be applied to the 2 and also to the x. And remember, when you expand things, multiplication turns into addition. So log base 2 of 2 plus 5 log base 2 of x. So here's the 2 and here's the x, and this stayed in front. It was applied. See how it had to be applied to both of these? That's why it remains in front of both. Now over here, we know when the base is the same as the number behind it, it doesn't just wipe out, it turns into a 1, and 5 times 1 is 5. And in back, I have 5 log base 2 of x. Final answer. Problem 21 and 22 are exactly the same kind of problem. So what this says is if we're going to go, we're going to say this right here is the contracted. It's been pushed together. Here's expanded form. I can see that it's expanded, right? It's being stretched out. So remember that when we go from expanded to contracted, addition turns into multiplication. So in doing that, think of it this way. Log base 3, and so I have 4 times some number. 4 times some number has to equal 16. Well, I know 4 times 4 is 16. So if I take this, I have log base 3s. They have to all be the same log base. You're not going to have to worry about that being different. And then remember, when we go from expanded to contracted, addition turns into multiplying. So 4 times 4 is 16. Same thing over here. So I have addition. So I think to myself, 8 times what equals 16? 8 times 2. 8 times 2 is 16. So log base 3 of 2 plus log base 3 of 8 equals log base 3 of 16.